Hi, this is Kevin Trainer, and welcome to part three of my coding assignment tutorial for Zelle chapter 11 of the third edition of the Zelle Python programming book. And in part three, we're going to be revisiting another data set that we've used before, the slot machine values. Okay, so let's review the data that we're working with. It's in a file that's one of your starter files. It's called slot values.txt. And there are 5,000 lines of text. And each one of them represents a pull, a try on a slot machine. And there are colors that come up. There are five values. And so we have the color names here. There are six different colors, but each pull, each try brings up five separate values. And there can be multiples. In fact, that's how you win, by having some combinations. Okay, and we wrote a program in a prior chapter where we analyzed each of the tries until we found a winner. Okay, now when I generated this file, I was expecting it to be pretty evenly distributed. I used random number generator when I did it. So over the whole file, over the 5,000 tries, the number of times that we get a particular color of the six should be pretty much the same. Okay, so if we count these up, if we do a count of each of the colors, including, for instance, duplicates. So in line one, we've got one purple, so we would add one to that. We've got two oranges, so we would add two to orange. We've got one blue, we'd add one to blue. One yellow, we'd add one to yellow. Then we go down to the next line, and the next line, and the next line. Now, when we add these all up, they should all be pretty close. Let's see, we've got 5,000 lines of five values, so that's 25,000 values. So they should all average around 25,000 divided by 6, more or less, if they're evenly distributed, which I think they are. And so they're going to be close to that, but not exactly that. So how can we analyze these data? Well, I wrote a program called Analyze Slot Machine Tries. Okay. And what do we do? Well, we prompt the user and we ask for the file name, and then we open it. Okay. And what we do is we create a dictionary that's going to hold the counts. Okay. So what's the key going to be for each entry? Well, it's going to be the character string of the color name. And what's the value going to be? Well, it's going to be an int, a value that's the count of how many times we encountered that color name so far. Okay? So we just use a for in for line and in file. Slot values gets assigned line split. Okay? They're separated by spaces, so we can just do the default for split. And then we say for slot value and slot values. Okay. And then here's what we do. We use the name of the dictionary, a color count, and which entry do we want? Well, the key is the slot value. Okay, that's going to be a color name. Okay. And what do we assign it? Well, we do a get on the color count with that same slot of value. And we say if it's not found, we want to take the default of 0, and whichever we get, either the value that's already stored or is 0 if we haven't stored one before, we add 1 to that. We bump that out by 1. So what's going to happen is we're going to read a line, and then we'll split it into 5 color names, and then we'll go through the 5 color names, and we'll bump up the color values that are on that line, and then we'll go up and we'll read the next line. So this is a nested for loop. Okay, so when we're done, we'll have read on the line, so we can close the input file. Okay, and then what are we going to do here? Well, we're going to say we want to put this out in some kind of order. Okay, now we did some work in a previous example where we wanted to sort them in a particular order, and so we built the data into a list of tuples. Well, what we're just going to do here is we're just going to do it a simpler approach. We're just going to print these out in key order. Okay, so how can we do that? Well, we get a list of the keys. Okay, and then we sort it. That's going to sort the color names into alphabetical orders. And then we iterate over the list of key values. And then we do a print. And what do we print? Well, a color count, get this key. Okay, we're always going to find it because that's where the key came from. It came from the color count dictionary. Okay, and what are we going to do? Well, we're going to format these such that the name of the color is going to be left justified and take up 10 characters. And the count is going to be right justified and take up 7 characters. And that's it. It's that simple. So let's give it a look. Okay, we're going to run this. Now, just before we get too far, let's make sure it ends gracefully if we give it empty input. So let's give it empty file .text. And it ended gracefully. Could have been a little more graceful, like no lines were processed or something like that. Yeah, it probably could. I'm just happy that it's not going to blow up when it gets an empty input file. Okay, now let's use the proper input file. Let's use, what's it called? Slot values.text. Slot values.text. And here we go. First of all, I'm always a little bit impressed when you read 5,000 lines that fast. Okay, and here's what we've got. Well, we've got 4145, 4087, 4198. If you add all these up, they're about a sixth of 25,000. Which is around where we want. So if in fact we generated this file over and over again, we probably would get closer and closer to the average if we had a lot more observations. So for, what am I saying? These would be closer to each other if we had, instead of 5,000 tries, we had 10,000 or 25,000 or 50,000. Okay, because what happens is that the averages, the law of large numbers begins to average out, and these things should all get closer and closer together the more observations we have. Okay, so this is pretty straightforward. It's like some things from the textbook. Um, it's not super fancy output. It's pretty easy to put it in the order of the key values. And quite often we want to do that. So I wanted to show you doing that. Okay, now you're going to do something very similar to this. Okay, I'm going to have you combine the code from this. Okay, so you're going to, in yours, you're going to analyze the slot machine values. But how's it going to be different? Well, it's going to be different in the following way. We're only going to count the unique values on a line of input. So for each try, let's look at slot values text. Okay, we would add one in line one. Let's make these a lot bigger. In line one, we have a purple. We'd add one to purple. We have two oranges. We wouldn't add two to orange. We'd only add one. Okay, so what we want to do is we want to find the unique values in the list after we do the split. So purple's a unique value, orange is a unique value, it'll get one more. Blue is a unique value, it'll get one more. We won't increment the count a second time for orange, only the first time, and we're only going to increment it one time for yellow. Okay, on the second line, we add one to yellow, one to blue, one to purple, one to red. The second blue doesn't get counted. Only the unique values get incremented by one. Okay, so so you're going to use just about the same code, but you're going to have one extra step, is that before you go and bump the counts up for the line that you're on, you're going to have to figure not what all the values are, but what are the unique values that are on that line. Okay, and so I'm giving you code that's going to help you with that. We have another kind of tutorial program here called Find Unique Values. So let's look at this. Okay. Now there are a lot of ways to approach eliminating duplicates from lists. If you do a Google search, you'll find maybe 5 good ways to do it. They're all, or most of them, are pretty fancy, right? And they use one that's really promising. Uses a data structure that we haven't covered called sets. Okay. Well, what we're going to do is we're going to do a pretty easy way to find the unique values. First thing, we're not going to change the list in place. Okay? We're going to create a new list. So what I did is I created a function called find unique values. So you pass it a list, okay, that can have duplicate values. We don't know how many multiple occurrences we have. And what we do is we build a list that has only the unique values from the first list in the order in which they occur in the list. So how do we do this? Well, we have a for. We have a for in, so we say for value in value list if value not in unique values, that's the result list, appended to unique values. So every time we come to a value, if we haven't already added it to the unique values list, we add it. If it's already been added, we don't add it a second time. Okay? And then when we're done, Unique values has a list of all the unique values that were in the original list in the same order that they were in the original list. Okay, so how do we demonstrate this? Well, I created a list with multiples. So we've got 2 ones. I don't think it really wants us to have a space before that one. Nope, it doesn't. 2 ones, 3 twos, 1 3, 1 4, 2 fives. Okay? And then, so we say that we want to print multiples and the list with multiples so we can see this. And then what we do is we say that the unique list gets assigned the output that comes from find unique values. It's a new list. So we call find unique values, and the input is list with multiples. And what does it return? Well, it returns unique list, and then we print it. Okay, well, let's just go run that and see what it does. Well, it works pretty darn well. So we've got 2 ones in the input, only 1 in the output. 3 twos in the input, only 1 in the output. 1 3 becomes 1 3. 1 4 becomes 1 4. 2 fives in the input becomes 1 5. Okay. So this is a very straightforward way to find the unique values in a list and to create a new list with only the unique values in the original order. Okay, and that's what that's going to work very well for your assignment. So your assignment is to take this analyze slot machine tries, okay, and to change it such that it only counts unique values on each line on a per line basis. Okay? And it's a combination of these 2 programs. A little more challenging than some of the things that we've done, but I think you're up to it. And so I'm going to wish you luck on that and say goodbye until next time. Bye-bye.